So let's go ahead and execute our plan. This is the equipment that we'll be using today. This is the standard angled blade plate set. You have your router. You have the positioning guide for the plate on the shaft of the femur that you see here. Some people do use the triple drill guide technique. We'll have multiple triangles to help determine angles on the actual model. You have the condylar plate guide, which we won't be using today. You have different sets of blade plates that we won't be using. We'll be using the osteotomy blade plate. You have the seating chisel. You have the slotted hammer. You have the inserter and extractor of the blade plate, and then the impactor as well. So just remember that this is a DC type plate. It's smooth on the undersurface, so you want to use the correct green gold guide with the smooth surface on the bottom. You also have the universal drill guide or drill sleeve that can be used for the 3.2 or the 4.5 millimeter drill bit. And just remember that the 3.2 drill bit is for the screws that you're using, which are the 4.5 cortical screws. The 4.5 drill bit will be used to create the cortical defect on the lateral aspect of the femur for where the blade plate, chisel, and then plate will go prior to using the router. And then you also have the K-wire drill sleeve here. So just remember that these are 4.5 non-self-tapping screws, and so you will need a tap to create the pathway for the screw and avoid using power to do this. You want to do this by hand. In the bottom of the basic set, you have the osteotome that we will use to complete the osteotomy. So first we'll go ahead and place our 90-degree reference wire to the anatomical axis. So basically you're placing this perpendicular to the femoral shaft, and you're placing it bicortical. So the triangle will verify that you're placing it at a 90-degree angle. And then we're also going to place a wire parallel to this to be able to place the blade plate chisel. So based on your preoperative plan, you will try to place this wire at the level of the blade plate chisel insertion, basically just right above it, because you have to allow for space for the blade plate chisel. So this one's going in perpendicular to the anatomical axis proximally, and this wire should be parallel to the first one. And you do want to verify that this wire is being placed within the femoral neck, so you want to correct for the natural aneurysm for the patient. So this patient doesn't have any torsion issues or version issues, so you want to place it down the axis of the femoral neck in the lateral plane. So you would do this with fluoroscopy, verifying that the wire is down the center of the femoral neck. And so then we'll go ahead and get ready to place the blade plate chisel. So this is the guide that can be used with multiple drill bits to be able to create a lateral cortical defect to make the chisel go into the cortex easier. And so basically you can use a K-wire to help hold the guide in place. As you can see, if I rotate my hand just a little bit, there's another wire in there to help control rotation. And then since you only have one 4.5 millimeter drill bit, you want to hold your guide as you're drilling the 3 holes. And so basically on the lateral view, you can see that there are 3 parallel holes there. This emphasizes the point that you don't want to start really truly in the center on the lateral view. You want to be anterior to where the piriformis fossa is, because otherwise your blade plate chisel can go basically through the cortex, out the femoral neck, and back into the femoral neck. So you want to make sure that you're starting truly within the center of the femoral neck. So you can see that on the lateral view. You can see the other K-wire that was through the guide to help position the guide as well as make it more stable while you're drilling your 3 holes with the 4.5 millimeter drill bit. And then we'll go ahead and use the router to create the path for the blade plate chisel through the lateral cortex. And so clinically, you can use osteotomes to create a defect in the lateral cortex to allow the blade plate chisel to create an easier path. But in the sawbones, this is a little bit easier to use the router since we don't have different sized osteotomes. So we'll remove that other helper wire basically that was helping hold the triple guide. And now we'll get ready to place the blade plate chisel. You'll set up the tuning fork and the blade plate chisel like this. This seems to be the easiest ergonomic position to hold your hand to avoid, number one, hitting it with the hammer, as well as being able to control the rotation effectively. So we have our trusty hammer mallet here. So as you're starting to place the blade plate chisel, you want to make sure that you have the plate guide attached to the blade plate chisel. You can see that it basically just slides over the blade plate chisel. It helps make sure that you're not changing the flexion or extension position of the plate. And so what you don't want to do is do your osteotomy and find that you've induced flexion or extension when you're trying to connect the shaft of the plate to the shaft of the femur. And so basically you'll go in as far as probably 20 to 30 millimeters, and then you want to back it out, because if you try to go the full length of the blade plate, you will have a hard time getting the blade plate chisel out. So this is a sequential technique where you're trying to avoid making it too difficult to get the blade plate chisel out, and you'll also be making frequent fluoroscopy checks to make sure that you're heading down the axis of the femoral neck on the lateral view, as well as making sure your depth isn't too far on the AP view. So you basically want to grab the slotted hammer, the blade plate chisel, and again, the tuning fork helps to also control the sagittal plane. So you want to make sure using the plate guide and the tuning fork that you know where the plate's going to end up on the lateral aspect of the femur on the sagittal view. So like I said, you're going to go in 20 to 30, and it may be less than that based on the patient's bone quality, but just go in a little bit. As soon as it starts getting difficult, then you want to start backing it back out. And this is important to also make sure that your blade plate chisel is sharp. So after a few uses, you want to make sure that your equipment's being sharpened as well. So I went a little bit further, and you can gauge the depth of the blade plate chisel actually on the chisel in reference to the lateral cortex. You can hear there that there's a pitch change, and like I said, you would be checking periodically as you're doing this on fluoroscopy in both the AP and lateral planes to make sure that you're not violating the femoral neck. One of the nice things about using the non-cannulated blade plate chisel is that the femoral neck cortex typically guides you down the axis of the femoral neck. It's more difficult to violate the cortex with the non-cannulated chisel versus if you have a guide wire in that becomes malpositioned as you're hitting it back and forth. You could have the wire kind of direct you to anterior or posterior to where you're at risk of violating the cortex, especially if the blade plate chisel is new and very sharp. So you can see on the lateral view that the initial 90-degree wire is in place, that it's important to make sure it's placed distal to where the plate guide is going to be placed. If you place it too close to the proximal femur, then as you're hitting your blade plate chisel and using the plate guide to make sure you're on the lateral femur in the appropriate position, you'll end up hitting it and then you'll have to take it out. So if you make sure that you start with it more distal to where the plate guide is going to be, then it's easier to get everything positioned well. So you can also see that reference wire is down the axis of the femoral neck, and the blade plate chisel looks like it's down the axis of the femoral neck, and we did not violate the anterior posterior femoral neck cortex. So to make sure we don't change the rotation profile of the proximal femur for this particular patient, we're going to place the 2mm drill bit distal to where the actual plate is going to be, and it will be parallel to the blade plate chisel handle. And we'll leave that in place. So you can see that that is essentially parallel to the blade plate chisel handle. And so now we'll take off the plate guide. So we'll use the 90-degree reference wire to place for the proximal cut. And you can also, your secondary reference is the blade plate chisel handle, because that was placed at 90 degrees as well. So the level of the first cut for the osteotomy is just above the lesser trochanter. And so we'll get ready, and you'll be verifying this fluoroscopically, but you want to go ahead and place the wire. And just here you want to place it bicortically, and just with the sawbones, the flexibility of the sawbones has allowed the blade plate chisel to go a little bit less than 90 once it was in, just because of the weight. But this transverse wire that you place first is your first cut, and the reason why that's the first cut you want to do is because then if you do have to change any of the rotation, you have a flat surface to change rather than trying to do it on an oblique surface. So it's really important to make that first cut the transverse cut. A lot of times patients that require an intertrochanteric osteotomy will have prior hardware like this patient does with screws, but particularly if they have a sliding hip screw or a nail where they have a larger hole in the lateral cortex, placing this transverse cut more proximally allows to incorporate that hole and make it basically further away from where that blade plate chisel is going in rather than making it an oblique angle. So we've got our transverse cut in. So now we're placing our 30-degree cut wire, and so we're basing it on what the template showed as far as how much leg length or head height we're going to change. And so the wedge you resect will affect the leg length or head height. So based on our templating, we're going to place the wire basically intersecting the transverse cut in approximately the middle section of the wire. So again, you're going to verify this fluoroscopically, and you want to basically place this wire outside of where your cut's going to be, because then you can use your wire as a cutting guide. And so now our reference wires are in place for the osteotomy. And again, we can use the blade plate handle as just to help control stability of the proximal segment. And we're going to go ahead and use that proximal transverse wire as the initial cut. And so try to use the wire as the guide. And again, you can see that I can't get quite up next to the wire. And so that's why you want to place your wires just outside of the area that you want to make your cut. And you want to leave just a small amount of medial hinge. And so before the osteotomy actually completes, we'll want to remove our blade plate chisel handle. And so we'll grab the slotted hammer. And so have your assistant go ahead and grab the femoral head just to create some resistance as you're trying to back out the blade plate chisel. Now we're going to go ahead and create the 30-degree oblique cut. And sometimes you have to change the position of the saw to be able to get around the wires that you have in place. And so clinically, obviously, the bone's not going to fall on the floor, but you can use this for later to create a bone graft to help with added stability, as I'll show. So once you have your reference wires in and you've got your bone cuts done, you can go ahead and remove your reference wires. So now we have the blade plate ready for insertion, and you can see that the insertion handle is parallel to the actual blade plate. And so have your assistant grab the femoral head. Just to create some resistance, you're going to grab the tuning fork because you still want to control rotation. And so this is where it's important to have made several passes back and forth to make this part of the case simple. And since you have the blade plate in, you can also take the proximal reference wire out. The Verbruge clamp will be used to help hold the plate down to the femoral shaft. Your assistant has the blade plate in hand, and now we'll go ahead and complete the osteotomy medially. And so they've got that positioned. So now we're going to go ahead and place the plate on the shaft. And you can position the plate initially with wires in place just to help control rotation. To create what's called mismatch compression, you're going to place a unicortical screw distally. And so really what you're trying to create is a fulcrum for the plate. So we're not going to get it completely tight because we want to create some offset. So basically with mismatched compression, you're trying to generate a fulcrum distally and then offset of the plate off of the bone proximally. And so as the second screw that we place, you'll create compression at the lateral aspect of the osteotomy, and it'll try to pull the shaft of the bone over to compress the osteotomy even more. And so in the clinical situation, the soft tissues will help kind of control this, but since there's no soft tissue attachment, we need to help kind of create a space. We've got the fulcrum screw almost completely tight. We're going to place the K-wire sleeve in place proximally to create a little bit of a space. We're going to tighten the fulcrum screw. So now we've got offset created. And so what we'll do now is go ahead and drill for this screw to help create compression. So we're going to go perpendicular to the bone, and it doesn't have to be necessarily on the far side of the hole. You want to typically just generate compression by pulling the bone over and not necessarily proximally or distally. So we're going to go right in the center of the hole, perpendicular to the bone, and just make sure you don't drill into your assistant's hand. So we're going to go ahead and start the screw. and then we can remove the K-wire drill sleeve, and then we'll go ahead and generate compression, and you should be able to see that lateral cortex starting to get shoved medially on the proximal segment. You can see the screw peeking out medially, and this has excellent purchase. And you can see that the osteotomy is well compressed. So I've gone ahead and placed a second screw. So this is the middle screw here. And if you want to generate some more compression, especially in weaker bone where the patient's more osteoporotic, you may have to do that to help spread out the forces of compression rather than relying on the initial screw that you placed. The other thing that I went ahead and did was to go ahead and exchange this unicortical screw out for a bicortical screw. I did want to show you that the importance of the reference wire or the reference drill bit distally. So you can see that if you look at this, that this drill bit is essentially parallel to the blade plate proximally. And so you can see that the plate is well centered on the lateral side of the femur. And then I went ahead and took the wedge that was resected and placed it medially, and that can be done clinically as well to cut down on the amount of time for bone regeneration or callus formation, and just use it as a bone graft. And it potentially could add stability if you have a smaller residual surface for the osteotomy to compress against. It can just add stability. The other thing that I wanted to mention is that we are using a 120-degree blade plate. And so you could say, well, why didn't we use the articulated tensioning device, which is in the basic set of the large fragment set? And you really don't want to use this device with a blade plate that's a higher angle than a 95-degree blade plate, because what can happen is that this can generate so much compression that it can actually pull the blade out of the proximal segment. So for a blade plate that's a higher angle than 95 degrees, you want to make sure to use mismatch compression like we demonstrated here.